Okay, well, good morning, everyone. Thank you for joining us here today as we dive into the world of acoustic monitoring. I'm Christine Schmaltz. I'm the Executive Director of the Delta Farmland and Wildlife Trust. First off, I just wanted you to know that we are recording this presentation. I think you will have had a warning pop up ahead of time to note that. And we hope to post this presentation on YouTube down the road to be able to share it with a broader audience. The presentation itself will last approximately 30 minutes, and then there will be quite a bit of time at the end for any questions that come up. So please hold your questions till the end of the presentation if you're able to. And if you can, keep yourself muted during the talk, that would be helpful. So Connor Haughey is our presenter today, and Connor's our wildlife biologist at Delta Farmland and Wildlife Trust. He comes to DFWT with a farm background and has studied environmental science at Trent University as well as University of Guelph. Connor's an avid birder and has a wealth of knowledge about all things bird related, which we value enormously in our work and our team. Over the last number of years, Connor's been with DFWT for over 5 years now. Connor's introduced a number of experimental sort of new strategies and approaches and ideas to enhance the impact of our research and our work overall, which have been very successful. And today he's going to be sharing his experience on acoustic monitoring for snow geese. So with that, I'll turn it over to Connor.
That's great. Yeah, thanks, Christine. So this project kind of covers the past 4 or so years of acoustic monitoring that we do in farmland in Delta, and yeah, and the various programs related to that. So just give a quick overview of the presentation. I'll talk a little bit about Delta Farmland and Wildlife Trust and our cover crop stewardship program for people who might not be familiar. And then how we monitor wildlife without the autonomous recording units, ARUs, and then how we kind of saw a need and a role for ARUs in our wildlife monitoring. We'll go a bit more into a recent project from the past year where we built a real-time ARU to address some of the challenges that we've had with other ARUs. And then we can talk a bit about what we've learned from these studies and future directions for this research program. So if you're not familiar with us, we're a nonprofit group based in Delta, BC, established by farmers and conservationists who were concerned about increasing pressures on farmland and wildlife habitat. So a lot of our programs use farmers to inform stewardship programs, but there is also a big scientific research component too. So our overall mission is to promote preservation of farmland and wildlife habitat, kind of using farmland as functional wildlife habitat in Delta. So we are very embedded with the local farming community, and we have several cost share programs to provide habitat for wildlife on farms, improve soil quality and sustainability. And we work all throughout Metro Vancouver and the Fraser Valley. So for this kind of program, the main stewardship program that's relevant to our bioacoustics monitoring is the cover crop stewardship program. So cover crops are planted in the fall, and their goal is to protect the soil over the winter and provide all sorts of soil benefits while also providing a wildlife benefit to migratory waterfowl. So in the lower left-hand corner here, you can see all of the fields in Delta and Richmond that were at some point enrolled in our cover crop program, which is quite extensive. So, you know, pairing this stewardship program, you know, with a solid research program monitoring the wildlife and knowing how wildlife use these areas is very important, because we've got almost 11,000 acres enrolled nowadays, and quite a few historically. So So I can talk a bit about how we got started with monitoring wildlife on these lands. So the first kind of survey we do is an on-the-ground vegetation survey, and we do these periodically throughout the winter because cover crops planted by farmers will be things like oats, rye, turnips, or some combination of those and more. These could be used quite extensively by migratory waterfowl during the fall and wintering waterfowl over the winter. So this little photos on the left here shows the same field over the course of the winter, just to kind of demonstrate the grazing pressures that some of the fields experience in our region. Between all the regions in the lower mainland of BC, Delta is by far the most impacted by waterfowl. Um, and so it's a really important focal region for us to study waterfowl grazing rates and to investigate how these waterfowl are using this habitat over the winter. So in addition to the on-the-ground field surveys that, are very labor intensive doing vegetation surveys, so it's not something we can do extremely frequently because we may have hundreds of fields in our program to monitor. So we also pair that with wildlife specific surveys, and in this case, the waterfowl surveys are road-based transect surveys. So we follow set routes through Delta and Richmond every week and tally waterfowl flocks based on what we can see from the road. So we're counting flock size and also the species involved. And then once the season's done, we can use some occupancy models to identify the kind of habitat features that influence occupancy probability. So here's kind of a breakdown in Delta. You can see that snow geese just make over about half of the total waterfowl seen by numbers in Delta, with mallards, widgeon, and cackling geese kind of following. But one of the tricky things with snow geese that we found is we know they're there, and from the first vegetation surveys, we can see their widespread impact on the fields. And despite such high numbers, we tend to not see very many flocks of them throughout the year. And one of the reasons for this is, and it's been reported by farmers as well, that snow geese have a tendency to use the fields at all points in the day early in the season, but it kind of flips suddenly and they switch more towards nighttime habitat use. And so they were kind of a species that is not being accurately presented with these in-person transect surveys because it's difficult. Well, we can't survey waterfowl flocks in the middle of the night. So, and we know based on population counts that the Fraser and Skagit flock of snow geese has just about doubled, if not more, since DFWT started these stewardship programs in 1993. So this was a big question for us, and I think a big opportunity to use bioacoustics to complement our in-person waterfowl monitoring. So we thought, the primary use of this would be used to fill in knowledge gaps, because the in-person surveys are really great for, non-vocal species or, having perfect confirmation of species, but also getting accurate counts of flock sizes. And even though the ARUs might not be able to, I still think it's incredibly understand habitat use, just a
Connor, I'm having trouble hearing you there. I don't know if it's just me or if it's yeah. I think you've lost your audio somehow. Sorry.
That's okay. I'll switch. Is that one better?
That's great.
Okay, great. Sorry. Did when did it cut out? Should I go back a little bit?
No, that just a sentence or two before. Yeah.
Okay, great. Yeah, perfect. So yeah, these ARUs had tremendous potential for us to complement our in-person surveys. So we had three goals, and we were aiming to deploy these ARUs in fields at the same window that we would survey the waterfowl on the fields with our in-person transect surveys. So that's kind of October to April. Our first goal is to confirm and really just assess the extent of the day-night habitat use in snow geese and also see if it's a factor with other waterfowl because we see a lot of mallard and widgeon during the day, but we were wondering, maybe we're underestimating the extent of their occupancy if they're also affected by a, kind of day-night habitat use. So that was the first goal. The other one with these ARUs, because they're monitoring continuously, was to investigate other factors impacting occupancy. So because it's, essentially monitoring 24/7, we can get really detailed data, in comparison to the once a week surveys. The effect of tide, the effect of weather, precipitation, really fine detailed pieces, and then kind of informing our program data. How does the cover crop variety play an impact, if at all, with these birds? And then a third goal with these, because they record all audio, was to see, yeah, if these trends also extend to other waterfowl or other bird species, and how each of these species interact and may partition use of these cover crop um, habitats. So we started after my first year, and the field season wrapped up in April 2022. I really thought it would be a good idea to get these recorders out. So we established 10 sites on Westham Island in Delta in the fall of 2022 into the spring of 2023. And from that previous map highlighting waterfowl occurrence data, it is our biggest hotspot in the region. So it's a great, um, study site to be able to reliably look at these snow geese. And it's well cover cropped. So it's kind of a win-win for us. It's an important flyover site as well, located along the marsh of the Pacific Flyway. So we deployed these recorders on cover crop fields. In the first year, we used Sun Meter Minis. And in the second year, we used bar LT ARUs. But yeah, they both kind of have comparable quality and results. Oh, and I should also mention we've since that initial season been able to expand to more sites on Westham Island and as well looking at some variety for off-island sites such as Richmond, Abbotsford, and different parts of Delta. So here's kind of our normal pipeline. So you can see a photo of the recorder just tied to a fence post here. So we would set these recorders out and they monitor continuously. So we would need to swap out batteries and SD cards as the batteries drain and the SD cards become full. And that was about every 3 to 8 weeks. Then we take the data back to the office, unload it onto hard drives, and process it in BirdNet. And since we are dealing with, continuous monitoring, unlike other bioacoustics programs, which would target for a dawn and dusk chorus, this monitoring was quite time intensive. It took several weeks, and we accumulated quite a lot of data based on this project. So after the processing was finished, we would then be able to look at the results and get the data analysis, and which would ultimately be informing our program delivery and communication of our research. So in the first year, this was every 3 weeks, but we found in subsequent years we could make the process a bit more efficient. So these are just some of the things that we did, which were successful for us. So we lowered the audio sampling rate to 22 kilohertz from 48, which made the audio files smaller, so the SD cards didn't fill up as fast. We reduced the sampling window. So instead of recording 24/7, we recorded 5 minutes out of every 15 minutes. So basically cutting our recording time down to a third, but still getting really good coverage. And then also getting a more powerful processor in our computer to decrease analysis time. But we still found, even with these, even with the extending battery life and reducing file size, it was still every 8 or so weeks, which isn't bad, but it kind of prevented us from expanding this monitoring program, much further than the 10 sites on Westham Island that we had originally planned, just because of the time and time commitments and, the data accumulation. So we had an idea after that first year in 2023. So this has been a few years in development, based on research of others, to have us, bring the analysis into the field using small microcontrollers. So in our case, we targeted an Arduino, which is very, very small and very low powered, and low powered enough that it could do the analysis based on solar power. And so in comparison to the previous kind of monitoring pipeline, this one has solar power in, so we won't be having to do battery changes. It saves the results to SD card, and the results, since the inference is done in field, are much smaller files than big audio files. So you just need one 32 gigabyte SD card for the whole year. And then, as I'll get into, we found this kind of setup would work great with an internet connection to have real time. So we are able to do the analysis and have the results out to farmers and ourselves for our program delivery much quicker than we would have with the previous methods. And so one caveat I should mention with this, because we're not recording the audio, the results are really only as good as the classifier. So we spent a lot of time developing the classifier, and for this, so 2025, the fall was the first year we did this. We paired them with the bar LT recorders so that we could evaluate performance of our units and also be able to compare Snow Geese to future years. So I'll kind of break it down into steps on how we made this real-time ARU. So we had a tremendous amount of audio from our previous monitoring program. Each site was roughly generating a terabyte per year. So we had a ton of good training data for training classifiers. So we chose to do a Snow Goose only classifier. So that consisted of us going through our extensive audio records and pulling out really good recordings of Snow Goose calls and a lot of non-Snow Goose audio. So that could be wind, planes, tractors, other birds as well. And so it's kind of training the model to just recognize Snow Geese in all forms, whether it's a few flock flyovers on the ground. We took Snow Goose recordings from a variety of circumstances, and it was great for us to have this data taken from the same environment where these units are going to be deployed. So we trained this in a platform called Edge Impulse, which is a very great user-friendly platform for training machine learning models, especially for biologists or other non-computer science folks. It makes it very accessible to train these models. So how it works is the model will take in 3 seconds of audio and very, very quickly can process it and give a confidence score on how well of a match it is to the Snow Goose audio. So we ended up with an audio that performed pretty well in lab setting. For bioacoustics people, we had a 0.94 F1, which basically just kind of is a great balance of, avoiding false negatives, false negatives and false positives. So the next step was deploying the model in the field. We chose the Arduino Nano 33 BLE Sense, which is, as I've mentioned, very low powered. It also has a microphone built in. And, the Arduino Nano is a very well supported platform for these machine learning programs from Edge Impulse. So that was kind of a natural fit. And then we decided to pair it with a 15-watt solar panel, which is kind of on the upper end of the panels that can output at 5 volts before you need dedicated charge controllers. It's quite a big panel for what we're using it for, and we also used quite a big battery. But we wanted to be sure that we wouldn't run out of power, because over the winter in Delta, it's fairly dark, gets a lot of rain. But with this setup, we found we only needed about an hour of sunlight per day at the darkest point in the year for this to be self-sustaining. So it worked great for us, and we had no issues with the solar panel. So it logged the data hourly to the SD cards, and, kind of already having this unit deployed in the field, we found big improvements to the processing time because it does the processing in the field. The battery life was not an issue the same way it was with the other ARUs, and our data storage issues were kind of fixed with this setup as well. So now that we had that kind of solid base, we decided we probably had enough power to also add an internet connection to this unit because the files we're saving to the SD card are so small, just kilobytes big. That could be something easily transmitted over a cell connection. So we use this platform, this board from a company called Blues, no card, and it's subscription-based usage, but our usage is very low. And it is all, very easy connected, no soldering with this setup either. And I'll give a link for the full parts list at the end of the presentation to the GitHub page, which kind of has the model and has all the detail on these parts for people who are interested. But yeah, basically just with a little Grove connector, we could connect our Arduino to a real-time clock and an SD card shield and directly to the Snow card with a little cell antenna at the top. But the cell connector does use quite a bit of power, so we decided to limit its usage to just once every hour. Because the Arduino is recording every 3 seconds, it would have definitely burned through our data limits and battery if we were updating that frequently. But for us, 1 hour seemed really, really great. So here's a pipeline of where our data goes. So you're standing in the field and the snow geese vocalize. The Arduino ARU classifies all sounds it hears every 3 seconds. And it accumulates those, and every hour it saves to the SD card, but also sends it to the Blue Snow card. And so when the Blues Note card receives that data from the ARU, it will connect to the internet and send a summarized portion of the data to our server. So for anyone who's interested, this is what worked well for us. We used a platform called Node-RED to parse the data, stored it in a database software, and then forwarded that to a graphing software, which also we can do the data analysis on the server. But we were also able to host our server through Cloudflare, so we could see the graphs in person in real time from the field, which was very, very cool. So this whole process from vocalization to Cloudflare is about 3 seconds, which is very encouraging. So here's an example of the dashboard interface from Grafana. And so it's a bit convoluted, but this is a kind of hourly summary. So it tells you this is the updated from the previous hour from 12:30 to 1:30 on November 21st of last year. The average Snow Goose confidence score was 0.13, but expressed as a proportion of the hour that works out to 8 minutes. Here's kind of the distribution of the confidence score. So a lot of time with no geese, and then some time with high certainty geese, and very little in the middle. And here is kind of a season summary of the graph. And what's great is it's about what we would expect, where snow geese activity is very high over the fall migration and getting into late October, and then kind of trails off as we enter November, but they are still present. So getting into some of the results from all of our different bioacoustics monitoring programs. So one of our original goals was to assess the extent of daytime, day-night habitat use. And with this continuous monitoring, it was great to be able to confirm how much more active snow geese are on fields at night compared to the day. So this on the x-axis here are summarized by hour. And on the y-axis are the proportion of time that snow geese were present on the field. So starting at midnight here, about 15% of the time. And this was really true across all sites on Weston Island, but this was just one site in particular for the whole month of November. Fairly high presence during the night, which kind of plummets around dawn and stays low throughout the day, and then spikes at the dusk. And so it was great for us to kind of validate what we've been seeing on our transect surveys, because kind of the 8 to 4 or 5 is our window for surveying birds on the field. So really just highlights how these tools are great to confirm activity on the field when we're not able to when it's dark. It is also kind of important to note that the pattern doesn't always look like this, and you will see a lot more snow geese out and about during the day early in the season when they first get here. And that is also true against all of our sites. So it is a much more even throughout the day at the beginning, and then it just kind of flips to this day night. And so we were really curious why this happens. So one potential cause for this could be predator avoidance, which could be bald eagles, coyotes, or even these geese avoiding waterfowl hunters. So I think the most compelling explanation to me was bald eagle avoidance, actually. So with these ARUs, we were able to, because we had the audio records, we used BirdNet to assess for snow geese as well as bald eagles and other birds. And you can kind of see here bald eagle activity really kind of has the inverse relationship to the snow geese, where there's very low activity at night, and then it spikes at dawn and plummets at dusk. And here's a breakdown by month. So October, before a lot of the overwintering bald eagles are here yet, the activity is fairly low throughout the day, and then it increases in October, increases in November, and yet again in December. And here are kind of both of those graphs overlap. So to me, this is one of the more compelling explanations. We did also investigate how snow geese activity between sites are different. So this is for one survey year. We decided to split Westham Island sites in half. So half were on the west side that we called marsh sites, and half were on the east side, closer to the Fraser River. And this graph in the top right here shows that over the course of the year, the pattern is broadly similar, so you might not expect much of a difference, but in the fall, the western sites along the foreshore marsh edge tended to have up to 3 times more presence of snow geese than the sites on the eastern side of the island. And during spring migration in March, that pattern was flipped, where the western side had not very many snow geese observations compared to the eastern side of the island. And part of that could be due to the western side being more heavily grazed, but we also know that the geese use these marshes when they're not on the fields at night. They're likely in the marshes during the day, so it makes sense that earlier on the geese would use farmland closer to the marshes earlier in the season. We also observed kind of an interesting trend I've been calling like a bit like rotational grazing. So we've found that the geese will also rotate around the island in clusters, kind of dividing it up and choosing areas to graze week by week. So this is the first week of November, then the second week and the third week, and looking at 3 different sites, you can see one site each week is being grazed disproportionately more than the others, which was very interesting. Presumably they're grazing the cover crop to the ground, letting it regrow, but then we also found they'll come back, and 6 weeks later there were also peaks at these, the blue, then the red, then the green in the same order. So that's also very interesting, and kind of a trend we wouldn't have been able to figure out with previous forms of monitoring. So great. I think it's also great to get into some of the challenges we've had and some of our fixes in case there are other people interested in using these kind of techniques for their own monitoring programs. So we found with the conventional ARUs, I would say we probably had 90% coverage from October to April. We had some issues with loss of coverage, sometimes with recording failure. For example, the bar LT ARUs, we had some of them because they're time synchronized with GPS. We found that they never could establish a GPS signal. So we would come back weeks later and found that they didn't even start recording because something was up with the GPS. So there are other issues with batteries depleting quickly in the cold, or if we get a big snowstorm like we've had a couple years, we can't get out into the field to do these battery changes on time. So overall, we're happy, but there was a lot more coverage that would have been great to have with these conventional ARUs. And ultimately we feel like it's difficult to scale these. We survey from Delta to Chilliwack. It's quite a large area, and going out every even 8 weeks is can be very demanding for such a big monitoring program. Especially if we wanted to move from the tens to dozens or something like that in the future. So the real-time ARUs offered a solution to some of these issues, but they also had some drawbacks which are worthwhile mentioning. So we only had this at one site. There was intermittent cell connection issues. Anyone who's been on West Island knows that the cell connection can be a problem sometimes. But that only affected one site. And so kind of how it would happen is we would get no update, but then we would get 2 updates the next hour. So we were still getting the data, but I think we could fix that pretty easy with a stronger antenna. Because there's no way to choose the cell carrier through the Blues node card system. We found overall the trend lines were very similar between the Arduino-based ARUs and the conventional ARUs, so that was very encouraging for us. We did have a higher false negative rate. So basically what that means is the ARUs, they showed the same trend lines, with the day-night, and looking at the same days at the same site, the trends were the same, but the Arduino ARUs tended to just, by a substantial factor, underestimate Snow Goose presence. And so I think part of the most likely reason for that is that it has a smaller detection radius, so it might not be detecting snow geese out as far, which actually might not be a bad thing because we're still need more data to get accurate assessments of the detection radius. But with conventional ARUs, we're working under the assumption of 500-meter diameter, which is quite big and could cover many cover crop fields. So maybe there is an advantage to a recorder that has a smaller radius that only looks at one field or a couple of fields. But we may be able to fix this issue because the microphone was mounted inside the box and the bar LT recorders are outside the box. So we'll look at that in future years. And also with classifier accuracy, whenever we are comparing the same site at the same time with these 2 different recorders, we will be able to improve the accuracy in the future. So any false negatives or false positives detected that we're able to verify, we can put those into the training model and improve the performance, field accurate performance for the field last year. I would say one drawback for this is if we're changing the model, then we can't very easily compare snow goose presence between years unless we do some normalization. So looking forward, we'll be looking to get a better model quickly and then just kind of keep it as it is. We did also find that this particular Arduino, you come up to the limits of the hardware pretty quick, which is expected for such a low-powered device. So we found it would be great, to measure bald eagle presence too, or snow geese, mallards and widgeon in addition to snow geese. But we are kind of coming up to limits in the RAM and flash storage with this particular model. So that's just something to note going forward. So in future directions, kind of going back to our original goals, it was great for us to use these tools to assess and continue to assess the daytime habitat use of waterfowl because they didn't always used to exhibit this trend. And I think it will be great to further examine the extent of this with other species. I'm not sure if I mentioned, but mallards and widgeon also do show a slight preference for night foraging over day foraging, also probably for eagle avoidance, but it's not to the same extent. Snow geese, which was, maybe up to 40 to 1 night to day. So these tools we think are very accurate and appropriate for answering this question. We do want to do some ongoing analysis, and we have such a wealth of data with this, every 3-second resolution, which was saved on the SD card. So this is a very exciting, the site level factors are, a very exciting frontier for this research, but it will benefit from more seasons and more sites to make a robust analysis. And then in terms of looking at how all these different waterfowl species interact on cover crop fields, we're exploring other classifiers which can have smaller data requirements for the hardware and also different hardware. What's great with this system is we'll likely be able to just swap out the Arduino Nano for a more powerful microcontroller, and these are a couple of the ones we are considering that can handle more species in future years. So I think this would be a great time to highlight our funders who've made this project possible. So for this project specifically, lots of amazing help and funding from the BC Waterfowl Society and the International Wild Waterfowl Association, and Ducks Unlimited and Environment Climate Change Canada for supporting us as long-term funders in our research and monitoring programs. And thank you very much. If you have any questions, please email me. And here's a link to the GitHub. I will be putting this presentation up on YouTube, which will also have a link to the GitHub page, which has our project files for this Arduino classifier, our parts list, and instructions on how to get started if you're interested in similar things. And I'm happy to take questions if anyone has any questions. Oh, yeah, that's a good question, Christopher. So he asked, were you able to use your data to estimate bird numbers? So that's something I've asked a lot of bioacoustics professionals, and I don't know if it will be possible with the snow geese. I think people have had success doing that with passerines and nesting birds who use habitat with much lower density. But I think, for us, I don't think it will be possible because, just based on, even if we're using volume, it's hard to tell close geese versus many geese. Far away, but that being said, with the real-time aspect of this classifier, I think the in-person is still the best way to estimate numbers. And so, with having that real-time aspect where the recorders are always in the field and we could have a network, we had one of about 12 recorders last year. I could go out and do targeted surveys to get a sense of the bird numbers. So I can, know with some confidence that snow geese are going to be in a particular field. And so rather than, staking them out, I think, there's an effort to have better informed in-person surveys. Yeah, that's great. Christopher's also mentioning people using night goggles for surveys at night. I think that's something I'll get up to this fall. You might see me wandering around um, in Delta in the middle of the night this year looking for these geese. Yeah, for the most part, we found them really active just at dusk. So hopefully won't be a lot of late night, but that's something we're looking at. And also there's a question about the flip occurring, which is a great question, from daytime to nighttime habitat use. So it kind of varies year to year, but we find it tends to happen about the third week in October. So again, it will depend when the geese are here. But, when you see snow geese come, as a force in the fall, they're really on the fields at all times in the year. But yeah, with these ARUs, it's great to confirm exactly when that flip is happening. We had thought it might coincide with the hunting window, but it is about 2 weeks off usually. Okay, thank you.
Okay, well, thanks so much, Connor, for the presentation. And please feel free to email Connor if you have any other questions that come up. And yeah, we'll maybe close out the conversation there. Thanks everyone for joining. We really appreciate your time and investment in this topic.
Yeah, thank you for coming.